Hello, dear listener, and welcome. Tonight, as the world around us gently quiets, and your own breath slows to a peaceful rhythm, we're going to embark on a journey deep into the very fabric of existence. We'll explore the unseen architects of our reality, the fundamental interactions that shape everything we know, from the smallest whisper of an electron to the grandest ballet of galaxies across the cosmic tapestry. Settle in, find your most comfortable position, and allow your mind to drift as we contemplate these profound forces that orchestrate the universe. In the quiet realm of physics, there exist these beautiful, irreducible phenomena known as the fundamental interactions, or sometimes, the fundamental forces. They are, in essence, the primal ways in which nature interacts with itself, not seemingly reducible to anything more basic or elemental. Imagine them as the most fundamental brushes used by the universe's artists to paint the canvas of reality. There are four, and only four, of these known to us, each playing its unique, indispensable role. They are gravity, electromagnetism, the weak interaction, and the strong interaction. Let's begin our gentle exploration with the one we feel most intimately, the one that anchors us to our very world, and holds the stars in their celestial dance: gravity. It is a force of immense reach, its effects stretching across truly astronomical distances. Look up at the moon, feel your feet on the earth, observe the distant shimmer of a star, and you are witnessing the silent, constant embrace of gravity. Its influence is long-range, meaning it extends far, far into the emptiness of space, binding together the grand structures of our universe, the planets in their orbits, the sun in its majestic presence, and the countless stars forming the luminous spirals of galaxies. It is the architect of the cosmic ballet, the unseen conductor of the largest scales of creation. Scientifically, our most profound understanding of gravity comes from Albert Einstein's general theory of relativity. It's a truly elegant and mind-bending concept. Instead of thinking of gravity as a pull, in the traditional sense, Einstein invites us to envision space and time not as a rigid, unchanging stage, but as a fluid, dynamic fabric. He proposed that the gravitational interaction is, in fact, attributed to the curvature of this very fabric, space-time itself. Imagine a bowling ball placed on a stretched rubber sheet. It creates a dip. Now, if you roll a marble nearby, it will curve towards the bowling ball, not because the bowling ball pulled it, but because the sheet itself has been deformed. In the same way, massive objects like planets and stars don't just sit in space, they warp it. And it is this warping, this elegant bending of space-time, that we experience as gravity. It's a silent, constant presence, always attracting, always drawing things together, without any opposing, negative, counterpart. This singular, attractive nature is what allows it to dominate over vast, cosmic distances, patiently building and shaping the universe as we perceive it. Now let's shift our gaze from the grand cosmic scale to something equally pervasive, yet profoundly different: electromagnetism. This, too, is a long-range force, its effects undeniably woven into the fabric of our daily lives, often without us even realizing it. The very light that allows us to see, the warmth from a heater, the technology that connects us, the structure of every atom in your body, all are expressions of the electromagnetic force. Philosophically, electromagnetism is the force of connection, of vibration, of perception. It's the dynamic interplay of charges, a constant dance of attraction and repulsion that brings stability and diversity to matter. Unlike gravity, which only attracts, electromagnetism possesses a dual nature, positive and negative charges. This duality is its defining characteristic, and it leads to astonishing complexity and balance. At its heart, the electromagnetic force is carried by a remarkable elementary particle, the photon, the very quantum of light. Photons mediate the interactions that create electric and magnetic fields. It is these fields that are responsible for the most fundamental binding in the universe, the attraction between the negatively charged orbital electrons and the positively charged atomic nuclei. This attraction, this delicate balance, is what holds atoms together. And from the intricate dance of atoms, we get chemical bonding, the very basis of all matter and life as we know it. From a simple molecule of water to the complex proteins in our bodies, electromagnetism is the silent choreographer. It gives us electromagnetic waves, which encompass an astonishing spectrum, including the radio waves that carry our voices, the microwaves that heat our food, the infrared that warms us, the ultraviolet that tans us, and most wondrously, the visible light that paints our world with color. It forms the very basis for all electrical technology, literally powering our modern existence. It's fascinating to ponder the relative strengths of these forces. The electromagnetic force is, remarkably, far stronger than gravity. So, why doesn't electromagnetism dominate the universe like gravity does? The answer lies in its dual nature. Large objects, like planets or stars, tend to have an incredibly precise balance, almost the same number of negative charges as positive charges. This makes them effectively electrically neutral. Because there's no net charge, there are no resulting strong electromagnetic forces between them over large distances. It's like two perfectly balanced magnets, their individual pulls and pushes canceling out, leaving only gravity's gentle, cumulative embrace to hold them together. It is this profound cosmic balance that allows gravity to triumph over astronomical distances, shaping the vast, uncharged structures of the universe, while electromagnetism busily orchestrates the intricate, charged world of atoms, molecules, and all the wonders of chemistry and life. The historical understanding of these forces offers a fascinating glimpse into the evolution of human thought. In 1687, Isaac Newton presented his profound theory, postulating space as an infinite, unalterable stage where objects move. He inferred that all objects with mass would attract each other, describing this with his law of universal gravitation. This implied an instant interaction among all objects, a kind of action at a distance, without any medium to communicate the force. This idea, while incredibly successful, troubled many, violating the Cartesian tradition that there should be no such unmediated action. Then, nearly a century and a half later, in the 1820s, a new concept began to emerge with Michael Faraday. As he worked to explain magnetism, Faraday inferred the existence of a field filling space, a medium through which force could be transmitted. This was a revolutionary idea, suggesting that forces weren't just instantaneous pulls, but rather manifestations of an altered space around objects. Faraday, with a visionary insight, even conjectured that ultimately, all forces might one day unify into a single, grand explanation. His intuition proved remarkably prescient. In 1873, James Clerk Maxwell achieved a monumental feat, elegantly unifying electricity and magnetism. He showed them not as separate phenomena, but as two facets of a single electromagnetic field. And in a stunning revelation, his equations predicted a third consequence of this field: light itself, traveling at a constant speed in a vacuum. This unification was breathtaking, but it also presented a profound challenge to Newton's long-held theory of motion, which relied on Galilean relativity. Maxwell's theory, if it held true in all inertial frames of reference, would contradict Newton. To reconcile this, scientists initially proposed the luminiferous ether, AM, mechanical medium filling all space through which electromagnetic waves, including light, would propagate. This ether would serve as the preferred reference frame for Maxwell's equations. However, as history unfolded, this Maxwell ether was later disproven, leading to the profound realization that Newton's laws of motion, while immensely successful, ultimately had to be replaced by the more encompassing theories of relativity. This journey of understanding, from direct action at a distance to fields, and from separate phenomena to grand unifications, highlights humanity's persistent quest to grasp the underlying simplicity and elegance of nature. Now, let us turn our attention to the other two fundamental interactions, the strong and the weak forces. These are not forces we perceive in our everyday world, for their influence is profoundly local, confined to the infinitesimal, bustling realm of the subatomic. Yet, their importance cannot be overstated, for without them, the very atoms that compose us, and everything around us, would simply cease to exist in their stable forms. Let's first consider the strong interaction. This force, as its name suggests, is overwhelmingly powerful, but only over incredibly short distances, typically within the nucleus of an atom. Philosophically, it is the silent, potent glue that binds the very heart of matter. Without it, the universe as we know it would fly apart. Within the intricate framework of the standard model of particle physics, the strong interaction is carried by a particle with a whimsical name, the gluon. Imagine gluons as tiny, energetic cosmic threads, constantly weaving and reweaving, binding together even smaller elementary particles called quarks. Quarks are the fundamental constituents of matter like protons and neutrons, which together form the atomic nucleus. Protons, for instance, are made of 2 up quarks and 1 down quark, while neutrons consist of 1 up quark and 2 down quarks. It is the strong interaction, mediated by gluons, that holds these quarks together with an incredible, almost unbreakable grip, forming what we call hadrons, a class of particles that includes protons and neutrons. But the strong interaction doesn't stop there. As a sort of residual effect, like the faint stickiness left on a counter after a strong glue has been used, it also creates the nuclear force. This residual nuclear force is what binds protons and neutrons together to form atomic nuclei. Think of it, protons are positively charged, and like charges repel each other intensely due to the electromagnetic force. Without the strong interaction, the nucleus would simply explode due to this electromagnetic repulsion. The strong force, at these incredibly tiny scales, is about 100 times stronger than the electromagnetic force, easily overcoming the repulsion and holding the nucleus together in a stable configuration. It's a remarkable feat of natural engineering, ensuring the stability of every atom, and thus the very existence of matter. This immense power, confined to such a minuscule space, is what unlocks the energy within atomic bombs and powers the sun through nuclear fusion. Next, we journey to the weak interaction. This force, while subtle in its range, is no less profound in its implications, for it is the force of transformation, of change, of the gentle, slow dance of decay and creation within the subatomic world. Philosophically, it represents the universe's capacity for fundamental change and evolution, mediating processes that allow one type of particle to transform into another. Like the strong force, the weak interaction operates exclusively at subatomic scales, playing its role within the nucleus of atoms. It is carried by a trio of unique particles known as W and Z bosons. These particles are much heavier than photons or gluons, which contributes to the extremely short range of the weak force. The primary role of the weak interaction is to mediate radioactive decay. For example, in a process called beta decay, a neutron within an atom's nucleus can transform into a proton, an electron, and an antineutrino. This transformation is entirely governed by the weak force. It's a fundamental process that leads to the slow, steady ticking of radioactive clocks, allowing us to date ancient artifacts and understand the age of our Earth. It's also crucial in the processes occurring within stars, influencing how they burn and evolve, ultimately shaping the elements that form our very bodies. Though its name implies feebleness, its transformative power is immense, allowing elements to transmute, constantly reshaping the composition of matter throughout the cosmos. All of these known fundamental interactions, gravity, electromagnetism, strong, and weak, can be described mathematically with incredible precision. For gravity, as we discussed, this description comes from Einstein's elegant geometry of space-time. For the other three, the story is beautifully different. They are described as discrete quantum fields. This means that at the most fundamental level, these forces arise from the excitations or vibrations within these fields, and their interactions are mediated by elementary particles, often called force carriers or messenger particles, which are described by the Standard Model of particle physics. The Standard Model, developed throughout the latter half of the 20th century, is one of humanity's most successful scientific theories, providing a comprehensive framework for understanding the electromagnetic, strong, and weak interactions. Within this model, the behaviors of elementary particles are beautifully described by the rules of quantum mechanics, QM. To make predictions about the probabilistic outcomes inherent in quantum mechanics, and to account for the speed of light and the principles of special relativity, particle physics uses a sophisticated framework known as relativistic quantum field theory, QFT. In this framework, force particles, which we call gauge bosons, like our friends the photon, gluon, and W and Z bosons, interact with matter particles, which are known as fermions. Everyday matter, including you and me, is composed of atoms, and atoms are built from these fermions, specifically up quarks and down quarks, which form protons and neutrons and electrons. It's a dizzying, intricate dance of these fundamental constituents, all governed by these exquisite rules. As you lie here, gently breathing, consider the sheer elegance and wonder of this system. From the silent, cosmic embrace of gravity, bending spacetime to hold galaxies in their grandeur, to the vibrant, dual dance of electromagnetism, igniting stars, creating light, and binding the very atoms that make up your hand. Then dive deeper, to the furious, invisible grip of the strong force, holding the nuclei of those atoms together against immense internal pressures, and the subtle, transformative whisper of the weak force, patiently reshaping elements, allowing the universe to evolve. These forces, though seemingly disparate, work in a delicate, exquisite balance. Gravity, dominant over astronomical distances due to its singular, attractive nature and the electrical neutrality of large objects. Electromagnetism, immensely powerful locally, building and sustaining the intricate world of atoms and chemistry, yet balanced out over cosmic scales. And the strong and weak forces, operating in the hidden, vibrant subatomic realm, ensuring the very stability and potential for change within matter itself. The historical success of models that reveal such profound relationships between these fundamental interactions has always sparked a deeper longing within the human spirit, a quest to go beyond even the remarkable Standard Model. The Standard Model, while incredibly successful, doesn't yet incorporate gravity. This leaves us with a grand, unfinished symphony. This longing fuels the ongoing efforts to combine all our forces into a single, comprehensive theory of everything, a unified description that would unveil an even deeper layer of cosmic harmony. And the human imagination, ever curious, continues to ponder even further possibilities. Some scientists hypothesize that a fifth force might exist, a subtle, as yet undetected interaction, though these remain tantalizingly speculative, adding another layer of mystery to the cosmic tapestry. Imagine, if you will, the sheer profundity of this orchestration. Every single experience you have, every thought you think, every breath you take, is utterly dependent on the precise interplay of these four fundamental interactions. Your body, a marvel of biological engineering, exists because the electromagnetic force binds your atoms together. The warmth of the sun on your skin, the light entering your eyes, the very chemical processes that allow you to think and dream, all are electromagnetism at work. The stable nuclei within those atoms, which are the building blocks of everything, are held together by the strong force, and the processes that shape the elements in your body, and the energy that sustains stars, are touched by the weak force. And of course, gravity, the gentle, constant pull, keeps you grounded on this beautiful planet, part of a solar system, within a galaxy, all held together by its magnificent, silent power. It is a humbling thought, isn't it? To realize that the universe, in its boundless complexity, is built upon such fundamental, elegant principles. These aren't just abstract concepts, they are the bedrock of our reality, the very source code of existence. They are the unseen forces that allow stars to burn, planets to form, and life to emerge and thrive. As you drift now, towards the threshold of sleep, carry with you this sense of wonder. Feel the quiet hum of these interactions, everywhere, all the time, shaping your world, sustaining your being, orchestrating the universe with an unimaginable grace. There is a profound peace in understanding that beneath all the apparent chaos and complexity of life, there lies an underlying order, a set of fundamental rules that govern everything. Let this understanding soothe your mind and relax your spirit. Allow the vastness of these concepts to gently expand your awareness, and then, slowly, lovingly, draw you into the comforting embrace of deep, restorative sleep. All is held, all is connected, all is in motion, guided by these fundamental, elegant forces. Rest now, dear listener. Rest deeply, and may your dreams be as boundless and harmonious as the universe itself. Good night.